and painless as possible. So I'm here to talk to you guys about the crayfish kill that happened this summer over in Tenmile Creek, which is just nearby here, just down the road south of us. So my name's Abigail Nickelson, and I'm with the Washington State Department of Agriculture, and more specifically with the Natural Resources Assessment Section. A little further, okay. I'll bring it up like this. How about that? Okay, good. So to give a little quick introduction about our team, the NRAS team, our goal is to protect endangered species and water quality while maintaining agricultural productivity. And we do this through several avenues, some of which including research, collaboration, outreach, and such. We have three main projects that we do on a year-to-year basis. One of those is the pesticide use data collection, where we get data about the when and where and what is used, what pesticides are used in the crops in Washington. And then the agricultural land use mapping we do every year as well. All the fields in Washington are surveyed by us either through GIS methods or windshield surveys. And then lastly, we have our ambient water quality monitoring program. We're actually going out and measuring these pesticides in the waters, if we find them or if we don't, throughout the growing season in eastern and western Washington. We do this in other streams and ditches in agricultural areas. So here's a little timeline of what happened. We happen to be up in the area for a different project. During this time period, there was a landowner that noticed the crayfish kill, and he submitted an ERTS, which is an Emergency Response Tracking System report, to the Department of Ecology. So they submitted that report over the weekend. It was June 20th, 21st, and the Department of Ecology received that report on the following Monday and dispatched some personnel, and they went and surveyed the crayfish kill and also collected some specimens. Then we were up there, that should actually be Thursday, June 25th, if you're checking your calendars. Went up there and we collected sediment samples at 3 different sites, which I'll go into a little bit here. So these are, this is a map of our 3 sites. And on this map, I have the locations where the sites were at on Tenmile Creek, and then in the blue, that would be a blueberry field. In the purple red looking color there, that is a raspberry field. And then the yellow colored fields would be other crops in the area. And this is actually what we do when we do our agricultural land use mapping. So on that Thursday, we selected these sites to sample at. And when we were sampling of the sites, we did see dead crayfish. And again, this was 4 or 5 days after this initial site report. So at the first site here, this is at the bridge crossing of Northwest Drive, and this was the most downstream extent of the crayfish kill observed by the Department of Ecology. And then we moved upstream from there. This was near the site of the initial report, and then once more moved upstream again to the West Hemi Road bridge crossing, and this is was the most upstream extent of the crayfish kill that was noticed by the Department of Ecology, and this is also where the crayfish samples were taken. So when we're going out and collecting this sediment, we didn't just take 1 scoop at each site. We're going around, and at each site we're taking several different scoops, and we're always taking the top layer of sediment, usually the top 2 centimeters of the sediment, so that we know it was the most recently deposited sediment that we could possibly get. From the 3 to 5 scoops at each site, we're going to composite those, put them in a jar, send them off to the lab. And also, where we're collecting these sediment samples, we collect some general water chemistry parameters with our probes. It's dissolved oxygen, conductivity, temperature, and pH, and this was to rule out any other stressors that may have caused this crayfish kill. As we've all been hearing about today, it was really hot and really dry, and those stressors could also affect this crayfish kill. So with that, once we got all of our sediment samples rounded up, we sent those off to the Department of Ecology's lab in Port Orchard, and then the crayfish samples were sent off to WSDA's lab in Yakima for the tissue residue analysis. So here are the results that we got back, and I'll go into a little bit more detail about what these numbers mean, but you can see that we did find bifenthrin and cypermethrin, and when I say cypermethrin, I'm meaning the zeta-cypermethrin that you would find in Mustang Max, for example. And yeah, so we found them at all three of our sites, and the highest concentration was found at our most upstream site, this TM14. And then here are crayfish tissue concentrations, and you can see that we did find the zeta-cypermethrin in the crayfish. So from this, we can gain that these crayfish were indeed exposed to the cypermethrin that we did find in the sediment. So what do we do with that information? We have it in the sediment, and we have it in the crayfish. So with that, we decided we're going to compare these concentrations to laboratory studies to see how bad, maybe how not so bad, these concentrations were. So here's that same table again you just saw, and I'm going to add in these columns here. These columns represent the LC50 concentrations found in these laboratory studies, and the LC50 concentration represents the concentration that would kill half of the organisms in that test. So with that, you can see that the bifenthrin concentrations there on the far left are at or even a little bit above what would kill 50% of the organisms in a laboratory test. And then looking at the cypermethrin, you can see that all these concentrations are pretty well above all of the LC50 for that laboratory study. So to bring that into comparison and into perspective, I've added a column here that talks about the times above the LC50 that those concentrations were. So you can see on the left, the bifenthrin was at or twice the amount of what the LC50 was. And then on the right, you can see that the cypermethrin was at 4 times up to 41 times over that LC50 concentration. So we know that killing half the organisms is pretty bad, but how bad is it? So we took it a step further, and we're now going to compare those concentrations to this LOC, or level of concern. And we calculated this level of concern using EPA's risk quotient method. And it's pretty simple math. We're taking that LC50 concentration that you saw in the previous table, and we're multiplying that by a safety factor to derive this LOC. And the safety factor is half, or 0.5. So anything above this level of concern is deemed to be a high risk for acute toxicity to non-target organisms of that pesticide. So as you can see, these numbers, the math is pretty simple here. These numbers are well above these LOC concentrations for both bifenthrin and cypermethrin. And again, to bring that into perspective, so we have these 2 new purple columns here. And these are the times above the LOC that these concentrations were. And the bifenthrin is at least double, up to 4 times over, and the cypermethrin 8 times over, up to 82 times over that level of concern concentration. So because we found such high numbers, we decided that we were going to go back and see a couple months later, mid-September, to see if anything was still there. Is it still there? Can we still see it? And we ended up finding not anything. So it was either degraded by the organisms in the sediment or washed down the stream by maybe a rain event. I think it had finally rained by that time. And yeah, we didn't see anything, so it wasn't there. So in summary, we did find cypermethrin and bifenthrin in sediment concentrations that were likely toxic to the crayfish. And those concentrations exceeded the LC50 and the level of concern for invertebrates at all of those sites. One thing I want to mention too here is that, again, there could have been other stressors. So these crayfish could have already been stressed out by the heat, low dissolved oxygen or whatnot in the waters when the cypermethrin and bifenthrin came through. So they could have even been more susceptible to these concentrations. And then with the follow-up, we didn't find anything, and that is an indication that was more of a unique event, one-time event, and it wasn't a slow release or slow loading from, say, a field runoff or a sediment runoff. So with that, I want to convey a couple messages here. It is uncertain how exactly these chemicals got into the water, or from exactly what products. We don't know that. But you want to avoid these situations in the future, certainly. So with that, you want to be really careful when you're applying near water bodies, and adhere to those no spray buffers that are on the label, and also proper nozzle size selection, and of course calibrating those nozzles before you apply. And then also other methods to help reduce that spray drift deposition into the stream by ways of such as planting vegetation along the streams. And my colleagues tomorrow will be giving a presentation about our work on that in the Fall Creek Nursery Room. That's at 4:20. So it was why we were up here in the summer. It was very exciting research that we did this summer. So with that, I can take any questions. And here is our contact information. Thank you very much.
The toxic products, do you suspect that then it moved in runoff water, or do you expect